Hello, children. How are you? I hope you all are fine and going on well with your study. Students, today I'm going to explain the Ohm's law and electrical resistance. But before discussing on the main topic, I'd like to explain this circuit diagram. Students, it is a simple circuit diagram in which three electrical components are connected. Students, this symbol represents a cell. Cell, you know, students, the source of electricity. And students, this smaller vertical bar represents the negative terminal of the cell, whereas this longer vertical bar represents the positive terminal of the cell. And students, this one is a key. And this key, you notice here, students, the upper and the lower ends of the keys are not touching to each other. Means this key or this switch is in off mode now. So when the two ends of the key touch each other, then this switch will turn into on mode. And when the switch will be turned on, the electric current will start flowing from the positive terminal of the cell. Students, you know that as per the conventional theory of electricity, electric current flows from the positive terminal of the cell. So this is the direction of electric current in a circuit. And flowing through the circuit, when electric current will reach this third component, which represents here a bulb, then this bulb will start glowing. And passing through the remaining part of the circuit, the electric current will come back or return to the negative terminal of the cell. The students, in an electrical circuit, electric current starts flowing from the positive terminal of the cell, and while it flowing through the circuit, whatever the components or electrical appliances connected to the circuit, they will start working. And students, one more thing I would like to say here, this electrical component, bulb or fan or other electrical gadgets, whatever be connected with an electrical circuit, they're also called, students, load or resistance. So students, I hope you understand how electricity flows through a circuit. Now students, Ohm's law. Students, German physicist Sir George Simon Ohm established a relationship between electric current and potential difference in an electrical circuit. And this relationship is known as Ohm's law. Students, Ohm's law says us that when some other physical conditions like temperature, pressure, etc., remain fixed or do not change, then the amount of electric current flowing through a conductor is directly proportional to the potential difference applied across its ends. Students, this law, Ohm's law, gives us this formula I proportional to V. And just reversing the variables, we can also write it this way, V proportional to I. When physical conditions like temperature, pressure, etc. remain fixed. So from this formula, we can say that the magnitude of electric current flowing through a conductor is decided by the potential difference that is applied at the both ends of the conductor. If the potential difference increased, then the amount of electric current flowing through the conductor will also increase, but at a fixed rate. And if the potential difference decreases, then the amount of current flowing through the conductor will also decrease at a fixed rate. Students, we know that when this proportionality sign will be replaced by an equal to sign, then we need to bring a constant. Student, here R is that constant. So this formula V proportional to I can be written as V equals to R into I. Here V represents the potential difference applied at the both ends of the conductor. I is the amount of current flowing through the conductor, and R is called, student, the resistance of the conductor. And what should be the value of R? It depends on the nature, length, temperature, and area of cross section of the conductor. Students, using this equation, we can get the value of any of these variables. Students, in an electrical circuit, if we want to get the potential difference, the value of the potential difference that is applied across its both ends, then we can use this formula V equals to R into I. If the resistance and electric current is given, and if we want to get the amount of resistance that is applied in that electrical circuit, then we can use this formula R equals to V upon I. Students, it is already told that the amount of electric current flowing through a conductor and the potential difference applied at the both ends of the conductor are directly proportional to each other. Means if the potential difference is doubled, then the amount of electric current flowing through the conductor is also gets doubled. And if the potential difference across the ends of the conductor is halved, then the current flowing through it also gets halved, because the electric current and the potential difference in an electric circuit both are directly proportional. But students, here we can say that electric current and the resistance of an electrical circuit are inversely proportional. Means if the resistance of the conductor is doubled, then the current flowing through it gets halved. And if the resistance is halved, then the current flowing through the conductor gets doubled, because the electric current and the resistance of the conductor both are inversely proportional to each other. So students, the magnitude of electric current or the strength of electric current flowing in a given conductor depends on two factors. One, the potential difference across the ends of the conductor, and second, the resistance of the conductor. Now students, we need to know in detail the electrical resistance. When free electrons move through a conductor towards a definite direction, then electric current starts flowing through it. But students, when electrons move through a conductor, then they collide with one another. And not only that, when electrons flow through a conductor, the atoms of the conductor gets positively ionized. So when free charges, free electrons move through the conductor, they face two kinds of obstruction. First one, the electrons collide with one another. This is the one obstruction. And the second obstruction, students, the positive ions, which comes on the way of electrons as an obstruction. And when electrons flow through the conductor, they also collide with these positive ions. And just overcoming all these obstructions, electrons can flow through the conductor from one end to other end or to a definite direction. And this obstruction, students, slows down the speed of electrons flowing through the conductor. This obstruction, students, called the resistance of the conductor. The property of a conductor, by virtue of which it opposes the flow of electric current flowing through it, is called its resistance. Means resistance is the property of a conductor which slows down the speed of electric current flowing through it. Student, resistance is denoted by the letter R, and it is a scalar quantity. And the SI unit of resistance is omega. This is the symbol omega. As per Ohm's law, the resistance of a conductor or in an electrical circuit, it is directly proportional to the potential difference, whereas it is inversely proportional to the electric current. Means if resistance of a conductor is increased, potential difference will also increase, and the amount of current flowing through it will decrease. And if the resistance is decreased, the potential difference of the conductor or electrical circuit will also decrease, and hence the amount of electric current flowing through the conductor will increase. So students, if we replace all this variable by the unit value 1, then we can get this one, that if in an conductor or in an electrical circuit, the potential difference is applied at its both end 1 volt, and 1 ampere of electric current is flowing through it, then the resistance of that conductor or electrical circuit should be 1 ohm. 1 ohm is the resistance of a conductor, such that when a potential difference of 1 volt is applied to its ends, a current of 1 ampere flows through it. So when potential difference is 1 volt and the current flowing through the conductor is 1 ampere, then that conductor would have a resistance 1 ohm. So students, I hope you understand. In my next video, I'm going to explain how are the resistances connected in a circuit. So students, keep watching. Thank you.